Welcome to section 10.1 part 2, factorial notation and permutations. In this lesson you will learn what factorial notation is, and you will understand what it represents in terms of mathematical operations. You will also learn what a permutation is and how to calculate the number of permutations of a set of elements. You will learn how to permute R elements from an n-element set, and you will learn how to count permutations of sets where there are repeated elements. Let's look at an example. So, I'm interested, how many different ways can we arrange the letters in the word cat? Well, let's just make a comprehensive list. I'm going to do this in a logical fashion. I'm going to start with the letter C, and then I'm going to think about the way I can rearrange the other letters. Well, if I start with C, I can either spell cat, or I could start with C and put the T first instead, C-T-A. If I didn't start with C, I could start with A instead, perhaps. If I start with A, well, I could either spell act, there's a real word, or I could put the T first again. If I did not choose C or A, I could start with T. And if I start with T, I could either put the A first followed by the C, or I could put the C first followed by the A. And now we're straight out of possible ways to arrange these letters, and you can try if you want to try to find another way to do it, but you won't. This is all of them. So let's think back to the fundamental principle of counting. In the first spot, in the first letter of the word, that is, I could choose C, A, or T. And if I chose C, then I have two other possibilities for the second letter, right? I could either put the A first, or I could put the T first. And then once I've done that, well, the last letter is fixed. It's whatever I haven't chosen yet. So just like the fundamental principle of counting, I have three possibilities for the first letter, two possibilities for the second letter, one possibility for the third letter. So that means that I have 3 times 2 times 1, 6 different possible spellings for the letters in the word cat. So each individual way of writing those letters is called a permutation of the word. So, and there are 6, 3 times 2 times 1, different permutations of the word cat. And in general, this is important, you definitely want to write this down, the number of different ways that you can order n things is n times n minus 1, that's the number less than n, times n minus 2, that's the number 2 less than n, and you just keep multiplying until you get down to 1. This process of multiplying a number by all the numbers less than it is called a factorial. And so 3 times 2 times 1 is called 3 factorial. You'll see that the notation for factorial is the number of things that you're permuting followed by an exclamation point. So this is written 3 factorial. And you don't have to yell it. You can just say 3 factorial. If you do yell it, people will probably be confused. So n factorial is n exclamation point. And you can calculate that, just as we did on the slide before, by multiplying n times n minus 1 times n minus 2 all the way down to 1. One important thing to mention is that 0 factorial is defined as being 1. The reason for this is there's only one way to choose 0 things from a set. Let's get a little practice with factorials. So, calculate 5 factorial. Alright, let's do this. Well, we know that 5 factorial is just 5 times 4 times 3 times 2 times 1, and then we stop because we're down to 1. Well, 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, 120 times 1 is still 120. Cool. Alright. Let's calculate 9 factorial. Well, we don't actually want to calculate 9 factorial. That would be horrible. So let's get a calculator to do it for us. So I'm going to do 9 factorial. Factorial is listed under Math, Probability, or PRB, and there's a little exclamation point. Hit enter again, and we've got it. 362,880. That's a big number. Okay. So you'll notice that factorials get really big really fast. So in our previous example, 3 factorial is just 6. 5 factorials all the way up to 120, 9 factorials in the hundreds of thousands, and you can actually totally freak your calculator out by doing big factorials. Like 100 factorial doesn't seem like it's going to be huge, but it is in fact enormously huge. You see your calculator has received so much multiplication that it can't handle it. Last time in class, we looked at the problem of this combination lock that I have, and the combination, I've totally forgotten what it was. But I do remember that when I chose the combination, I didn't choose any numbers that were repeats of one another. There were no duplicate 1s or duplicate 8s or whatever. It was all different numbers, all distinct. We were curious exactly how many different ways could you try different combinations with that rule in mind. And so what we did was we said, well, our first wheel, well, that has 10 different ways that we can choose a number for it. But once I've chosen that number, when I go on to the second wheel, I can't choose the number again because there would be a repeat. And so there's only 9 ways to do that. When I get to the third wheel, I can't choose either of the numbers that I've just chosen, so there's 8 different possibilities there. And so by the fundamental principle of counting, I multiply those 3 events together, those 3 different wheels, and I get 720 different ways to do it. And so I've got a question, which is, how does this relate to factorials? So pause and think about how this relates to factorials, and join me again in a second. Alright, welcome back. So how does this relate to factorials? 10 factorial is 10 times 9 times 8 times 7 all the way down to 1. That's 10 factorial. And what we have here is just 10 times 9 times 8. So what we would really love to do is to get rid of the 7, 6, 5, 4, 3, 2, 1 in it. How do we do that? This is multiplication, right? How do we get rid of factors? Pause again and join me again in a second after you've thought about this. Alright, so how do we get rid of those guys? Well, we'd like to cancel them. And you can cancel multiplication by doing division. So what should we divide out? Well, we only want to divide out 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Note that that is, by the way, 7 factorial. If we do that, well, the 7s will cancel, the 6s will cancel, the 5s will cancel, the 4s will cancel, and so on. And so this fraction here, 10 times 9 times 8 times 7 times 6 times 5, all that, that really just boils down to 10 factorial divided by 7 factorial. So the formula for ordering r elements from an n-element set is n factorial divided by the quantity n minus r factorial. And you can see that here, right? This is 10 factorial, and we want to divide that by 7 factorial. Well, 7 factorial is really 10 minus 3 factorial, where 3 is the number of wheels on our lock, right? We're choosing 3 of our numbers, and that's the bit that we have to divide out to figure this out. So there's actually a button on your calculator that will do these calculations of permutations of subsets of numbers for you. So let's just do the exact problem that we just did. In this problem, we were interested in taking 3 numbers from the set 1 through 10, or I guess I should say 0 through 9. So there are 10 choices, 0 through 9. And then I will go to Math, over to Probability again, and I'll take NPR. N is the number of items that comes before you enter this function. P stands for permutations, and R comes after you enter this in there, and that's the number of items that we're taking from the 10-item set. In this case, we have 3 numbers in our combination. So If I hit enter, I will get 720, which is exactly what we calculated before. Let's take a look at our next example. So you're in an English class, and you have 5 books to choose from to do an assignment. You need to read 2 of these books, and on one of the books you need to do a presentation, and on the other you have to write a paper. And other than that, there are no restrictions. So the question that we have is, how many different ways can we do this assignment? One of the things that I think helps in a problem like this is to boil this down to just numbers. So we have 5 books to choose from, and I'm not going to get specific about them at all, but I'm going to call them different things. I'm going to call one of the books Book 1, I'm going to call another book Book 2, I'm going to call another book Book 3, and so on. So I'm going to have 5 books, and I'm going to label them 1 through 5. We need to read 2 of them. On one of them we need to do a presentation. So I'm going to put a slot here and write pre under it for presentation. And then I'm going to put another slot here, and I'm going to put PAP for paper. So what goes in these slots are these numbers, right? We can choose book 1, for instance. Well, then we could, if we want to do a presentation on book 1, we put book 1 there. And then for the other book, maybe we chose, I don't know, book 4. So there's one possible permutation. So what am I getting at here? Well, I'm getting at the idea that there are 5 objects that we can choose from. So I'll do 5 factorial. But we're only taking 2 of them and ordering them. So I'm going to do 5 minus 2 factorial by following our rule here for taking r elements from an n-element set, n factorial divided by n minus r factorial. I'm taking 2 elements from a 5-element set, so 5 factorial divided by 5 minus 2 factorial. And that gives us 5 factorial over 3 factorial. And again, we can use our calculator to determine what this value is again for us. Well, that's 5, and then we're going to go math, probability, NPR, 2. 5 objects, permuting 2 of them. And it gives us 20. So there are 20 different possible ways that we could do this assignment. So now we come to the last section of this chapter. And this is permutations with repeated elements. How many different ways can we arrange the letters in the word eel? So here, our set of elements is letters E, E, and L. And there's a repeated element in it, unlike the situation where we had cat with C, A, and T, where they were all distinct letters. Here we have 2 letters that are the same. So the way I'm going to go about solving this is exactly the way I went about arranging the letters in the word cat. But let me do this like it was cat. And the way I'm going to do that is I'm going to use a capital E followed by a lowercase e and then an L, so that our e's are different. Well, now I could do E lowercase e L, or E L lowercase e. Or if I didn't choose E to go first, I could choose the lowercase e to go first, and then L uppercase E, or E uppercase E L. Alright, so there are 6, right? Just like there was with cat. Obviously, I mean, we're doing the same thing. We're taking 3 different things, and we're permuting them. We're changing the order that they're in. But what if I made them so they were all uppercase? Alright, well now they're all uppercase. Well, what ones are duplicated? We see that there's 2 ELEs. I don't need both of them. We see there's 2 EELs. I don't need both of them. And we see there's 2 LEEs. I don't need both of them. So this really divided our possibilities in half, right? And so we see that there are 3 ways to do this. In fact, if you want to order n elements where there's an element that's repeated k different times, there are, in fact, n factorial divided by k factorial ways to do this. So if we look back at that, there are three things we have here, and two of them are repeated. Or I guess you could say one of the things is repeated twice. So in that case, that gives us three elements. That's 3 factorial, divided by the number of times that one of those elements is repeated, 2 factorial. 3 factorial over 2 factorial is 3 times 2 times 1 divided by 2 times 1, leaving us with 3. Let's practice this. For example 4, how many different ways can you arrange the word orderer? Well, the first thing to do is to think back to our formula, n factorial divided by k factorial. So we have 7 letters in this word, so we know that our numerator is going to be 7 factorial. Now, we have r repeated 3 times, so in the denominator goes 3 factorial. But notice we also have e recorded twice in this word. So the way to deal with this is actually also to divide by 2 factorial. So what we're going to do is do this on our calculator. So I'm going to go to 7 math, probability factorial, and then I'm going to divide that by, and I'm going to put this in parentheses because I want to multiply this stuff first, 2 factorial times 3 factorial, close up my parentheses, and there we have it. There are 420 different ways to arrange the word orderer so that they are unique. Alright, so that's everything. So we've now learned how to use factorial notation and the factorial procedure to assist in counting. We can count the number of permutations of a set. We can also count the number of permutations when we're taking only a small subset of the number of objects we have to choose from. And we can also count the number of permutations where an element is repeated. See you in class.